A die was rolled a number of times. The outcome as shown in the table. If the probability of obtaining a 2 is 0.15, find the A. Value of M, B. Number of times the die was rolled, C. Probability of obtaining an even number. So let's start with A, the value of M, that is this M here. Now let me first explain this table. This is the number that appears on the sides of a die. We have the phase 1, phase 2, 3, all the way to 6. And then for us to have 32 here means that we had 1 32 times. We had 3 25 times. We had 6 45 times. So if you want to find the total number of times the die was rolled, this is simply the total number of times the die was rolled. This comes from how many times we had each of these phases. Do you get? It's just that we are not told the number of times we had 2, and then we are asked to find the number of times we had 2. Now, what relationship will bring this M into an equation? And there will be a relationship between M and 0.15. Okay. First, if we are asked to find the probability of obtaining a 6, this 6 here, what will be our work? What will we do? We simply say probability. How many times we have a 6? That's 45. Divided by what? The total number of times the die was rolled. I hope you understand that. Does that make sense? This is the total number of times I got 6 out of the total number of times I rolled the die. Remember what probability is? Number of desired outcome divided by number of possible outcomes. Is that okay? So now this is going to be 45 divided by, let's add all these together. It gives us 170 plus M, because M is not a number, I can't add that. So if I knew what M is, this will be the probability of obtaining a 6. Now, so how can I factor this in? How can I relate this to finding M? I'll come here to this column, and then I'll say find the probability of obtaining a 2. Okay, so I'll be doing probability of obtaining what? A 2. That will be what? Number of times I got a 2, which is M that I'm not given, divided by this. Is that okay? So I'll go ahead and do this, but since I've already done that, I'll simply say 170 plus M. If you are solving, please, this is where you start from. You write all this down and then you get this answer. I hope you understand. But this doesn't leave us hanging like this. Okay, we are told that the probability of getting a 2 is what? 0.15. So you see, now I've gotten an equation where I can solve this. So let's go ahead and solve that. So that will be M all over 170 plus M is equal, so I just want to make this a fraction. Since I've done that, that will be 1 2. Are we familiar with that? Now I can cross multiply. So M goes here and becomes 100M is equals to 15 multiplied by all this. So that is 170 plus M. So let's multiply that out. 15 times 170 is what? That is 2550 plus 15M. That's 15 times M. Now I can send M over here and collect like terms. So that will be 100M minus this 15M. Is that okay? Will be equals to 2550. Now 100 minus 15 is what? That is 85M is equals to 2550. Now I can divide both sides by 85. And then punch your calculator. That gives you 30. So my M is equals to 30. So we've gotten the value of our M. Is that understood? So B says find the number of times the die was rolled. I explained that already, that this is the total number of times this die was rolled. Okay, we got 1 32 times, got M now 30 times, got 3 25 times. So all we need to do is add this up to get the total number of times this die was rolled. Is that okay? So we're going to go ahead and add this. So that is, we have 32 plus, let me just write the formula we had first out, plus 40 plus 28 plus 45, but m is what? 30. So we have, and that is going to give us 200, and that is our B. Now let's go over to C. C says find the probability of obtaining an even number. So what's the probability of obtaining an even number? Who are the even numbers? There are 2. I can have a 2, or I can have a 4, or I can have a 6. Those are the only even numbers. Now in probability, the probability of having 2 or 4 is we add the probability of having 2 plus the probability of having 4 plus the probability of having 6. Is that okay? That is how we handle probability when we see or in math in probability. So this is going to be, what's the probability of having a 2? We have a 2 was what? 30 over what? Total number of times, that is 200, plus probability of having a 4 is what? 40 over what? 200, plus probability of having a 6 is what? 45 over 200. So a common denominator, 200, right? All I have to do is add this top, right? And when I add that, what do I have? I have 115. Now something can cancel, 5 can cancel, so 5 goes here, 2, 1 remains, 5 goes here, 3, right? So 5 goes here, we have 4 and then 0, so that is 23 over 40, and that is our answer.